Good morning, good afternoon. Thank you for joining our first how-to webinar series on data normalization. My name is Al Hilton, the moderator of today's session. Our presenters today will be Bill Grant, Senior Director of Technical Sales and Services in EAL Oz, Vice President of Research and Development. Without further delay, I'd like to introduce Bill Grant, Senior Director, Technical Sales and Services. Bill?
Thank you, Al. Thanks, everybody, for joining. So first, before you get into the details here, I just have a quick disclaimer here. This is definitely an advanced training session. Now, that doesn't mean you need to know anything about normalization. It doesn't mean you need to know everything, but there is some information that you should already know about. We'll try to give some introduction as we go through this, but realize things like when I use the word environment or app def or discovery or collection and things like this, there's some assumption that you're familiar with Evolven enough to understand what those are. So if we cover anything in today's session that is unclear, or if it's a concept that you're not familiar with already, please definitely let us know. We'll definitely do a refresher training with you and get you up to speed, and you'll be able to listen to the recording of this again after that and make good use of it. All right, well, here's today's session. I'll first go through some Evolven terms, some things that you definitely need to know as I refer to them across. It won't be an exhaustive list, but just a few to make sure we know what we're all talking about. Then I'm going to cover what normalization is. I'll talk about what needs to be normalized, a few examples of those. What's the result of doing a normalization? I'll show you what the auto normalization feature is. And we'll look at how matching is different. And then we'll take a look at that actually in Evolven. I'll cover a little bit about regular expressions. So we'll give you a brief tutorial on regular expressions. And we'll also look at where you can define normalizations as well, so where you'll see those in the product. And then finally, we'll look at how to manage normalization. So when you create these rules, where do they end up? And I'll briefly talk about where the normalization is going in 5.6. We have our VP of R&D who also can tell us a little bit about where things are going. And then, as Al had mentioned, at the end we'll cover Q&A. So if you have any questions, please definitely write those in the questions tab. We'll get to as many as we can. Okay, so first let's cover a few terms that hopefully should be familiar with to you in Evolven. The first one is an environment. Environment is one of these overloaded terms that gets used in a lot of different ways, different products and different contexts in IT. When we talk about environment, we're talking about specifically a technological component or group of components with a configuration and content in Evolven. So an operating system or an application server or an application that's deployed in an app server or a web server, a specific directory, these are all environments. In the examples I'll show, we'll see folders that are represented as environments, and that's going to be relevant when we show these rules. And when we use the word app def, or also known as application definitions, this is the model that specifies how environments are discovered and collected. So think of it as we have essentially a template. The template goes out and says, this is how you would find this thing, and then this is what you should collect. And if you think of a simple folder collector, it would say, here's where the directory should be. If you find that directory, then go and collect the details. Now this app def also can contain impact and normalization rules, and some of those are shipped out of the box with Evolven. When we create normalization rules, they will not be within these templates, but they'll actually be stored in the Evolven system. So for those of you that maybe have been around for a while, didn't know that, impact and normalization rules actually can be stored directly in the system, and I'll just kind of point that out a little bit so you see it. And then finally, an analysis plan. This is a plan which defines what environments are being compared and how. The how is how did things line up in terms of the comparison. So we'll take a look at that a little bit as well, some of the newer features of how analysis plans look. Okay, so let's get into it. So what is normalization? Normalization is a feature that we use to compare data using the same patterns, but with environment-specific values. So think of the idea here. I've got on the bottom C Windows as a file system. And if you'll notice, there's a little N in the configuration tree that signifies that this item has been normalized. And what it says is that this is the etc dir. This is our standard for how we write variables, $, a curly brace, and in etc dir. That indicates that that's the replacement. So now, if we looked to compare the Microsoft Windows 10 environment to another server that also had the operating system, then it really doesn't matter where this etc dir is. If it's somewhere else, then that will get normalized and we'll treat them as the same. So that's really the intent of normalization, is to make things look the same for the purposes of comparison. So when do we need to do this? Just give a few examples as we go down the line. The first one is random numbers or GUIDs. In some cases, you'll see concepts where there will be some number attached to something. For example, sometimes what a system will do is say, take the first 10 characters and then apply some random number at the end. So if you want those items to align, you'll need to essentially mask out the numbers that will never line up correctly. Could be dynamic names. We'll see an example later, but sometimes you'll see a version number stuck in there. Now, if the version number is intended so that you only compare the 7-zip 9.00 with other 7-zip 9.00 items, then maybe dynamic names are fine. But if you do want those things to align, perhaps you might, for example, do a release where your new release always has the version number in it, but you want to know specifically how those differ. You'll need to normalize out the numbers. And so dynamic names would be a good example of something that needs to be normalized out. Environment-specific names are very common. When I work with clients, I would say this might be even the biggest one that we see, and it comes in a few different forms. It could be within folders themselves, or it could even be within a particular string. So either way, this is the kind of thing that we'd want to normalize out. Now, in some contexts, you want to know they're different, and that's fine. But if, for example, you have a configuration file, and one of them is called configuration.dev, and the other one's called configuration.prod. If you don't normalize it, you'll simply know that there are two different files, and you have no idea if the settings are different or not. So normalization allows you to treat those as the same for the purposes of understanding those lower level details. And then finally, host-specific directories and parameters. This is one that I just covered in terms of the etc directory, but even the Windows directory as an example would be something that would be unique. And this is just a sampling, but just gives you some idea of when normalization comes into play. So what's the result of doing a normalization? Well, first, before we even talk about a result, let's talk about what would happen if we didn't do normalization. So here we have two servers, host 1 and host 2. On host 1, you have a cwin directory. On host 2, you have a dwindows directory, and this comparison is run. Now, when you run this, what you'll see are only two differences. You'll see that on one system, there exists a folder called cwin, and on the other host, you'll see that there's a folder that is called dwindows. You have no idea if the contents are similar, because they're not the same concept. They're completely different, and so all you see is that there are two differences. And really, that's all. At that point, all you can do is to say that they're different names, and there's no way to know if the contents are different. Now, if we do a normalization, and in this example, we said that this is the win directory. In Evolven, this would be automatically handled for you, but in other contexts, you may need to create a rule to make these things line up. Then when you do this in this case, you would actually see 4 differences. You would see that my file 3 exists on one host and my file 4 exists on the other, and same thing with that my subfile 1 versus my subfile 2. Now, I should say you will see at least 4 differences, because my file 1 and my file 2 are now aligned, there may be details that are being collected of those files that now also will show differences. So the point here is that the count will be different. And I think that's, one thing to keep in mind about normalizations is when you do these normalizations, you will see a different result or a number of differences that come back. It often will be more because the contents within it will begin to align, and there may be some sub-differences. But not necessarily. It may also be that once you align them, suddenly there are no differences, that everything is the same. So the point here is that there will be a difference that's confusing, but a difference in count of the number of differences that you see. Okay, now one feature I'd like to just point out is that some things are able to be auto-normalized. And what that means is that Evolven is trying to determine what things should be normalized and just do that normalization for you. So I can put that into two places. One is the auto-normalization feature, which is trying to figure out what things should be normalized. And in other cases, there simply were, as part of definition creation, as part of the app defs that were created, those also were normalized as part of somebody determining that specifically those things should be normalized. So both of those things apply, but here we're talking about auto-normalization, where the system is trying to figure out which things should be compared. And I'll say that by default, you should simply use the default settings. In other words, this is not something that I typically will recommend that clients change unless they really know what they're doing. So I guess I'll leave it at the point of just being aware that within the server settings, that is where you click your username and you go to the server settings if you're an appropriate permissioned administrator. You'll see that there are auto normalization settings underneath the server settings. And you'll see the first box is really the main one that you would typically change, is whether this feature is enabled or not enabled. And in the purposes of this session and the purposes of my general guidance is to change that, under the guidance of your Evolven team. We'll tell you when anything needs to specifically be changed, but generally speaking, that feature will do its work for you. And you will see, for example, the results of these normalizations on the configuration page here. I'm looking on the inventory screen. I'm looking at the specific environment, and then you can see normalization parameters that have been identified. Okay, so that's where they live. Okay. Now, one thing I want to separate from normalization, and what I would say is these are separate but related concepts. I think that's an important thing to understand. Normalization, you'll see us apply normalization on specific configuration items. What matching is a very specific alignment that's done in analysis plans. So what I mean by that is that those are rules that are applied only to a specific analysis plan. And its intent is very similar, but it's for environment aligning versus these specific items. So let's take a look at an example here. We've got on the left side, I've got here's 6 environments. We have a folder and then 3 subfolders. And then here we have the same story, another folder and then 3 subfolders. And what we're trying to do is compare this match app prod with match app QA. And when we do that, what we find is that A, B, and C are identified as folders, and X, Y, and Z are not shown, in the sense that A, B, and C as your source are going to show up, and then it won't know on the right side what to align, because by default, X, Y, and Z have nothing to do with A, B, and C, and that would be the normal situation, would be that those are different. To handle that situation. And I guess I should say you can either handle it with matching rules, or you could manually associate A with X and B with Y and C with Z. So that's an example of matching. I'll cover it as a sample, but realize that this concept is not the same as normalization. Normalization is going to be aligning the specifics, and in terms of environment alignment, that is handled via the matching rules or by manually associating environments with other environments. Okay. So let's take a look at this example. So here again, I'm in the Evolven interface, and I have this these two environments that are here. And if I look at the analysis plans, I've got an analysis plan that I've created with this as the source and this as the target. So I'll go ahead and edit that plan. And I can see here that right now, currently, A, B, and C are here, and there are no subchildren that have been matched. So according to this, we only have a 10% comparison in terms of how these things are aligned. If I actually looked at the results of such a plan, I would see that I've got, 3 differences. It's showing me that A, B, and C exist. Have no environment. It's a missing environment. So essentially think of that as, if you recall, and hopefully you're familiar with this, that within Evolven, the source dictates what is compared. So because of that, X, Y, Z don't really exist to me. All I know is that A, B, and C are not aligning with these X, Y, and Z folders. Now we can handle this, and as I said, we can do this in one of 2 ways, but one of the ways that we could do that would be by simply manually matching. So I could say that this is I'm telling it that A should be matched with X. Now the other thing that I could do is create a matching rule. And so if I click on the matching rule, you'll see all the matching rules that are there. Currently there are none. And I can go ahead and create a rule. So I could say something like, I'll call my rule B or Y, and I'll say it's going to be a pattern. And the way that I can do this we'll talk about this in a little bit, but I'll just create a regular expression that essentially says B or Y, and then I'll just give it a value. And essentially I'm saying that if it's B or if it's Y, then I'm going to replace that with B or Y. That's going to be my particular matching rule. And when I save that and close it, I'll see that the B and the Y now have matched because it figured out that the B is going to be called B or Y and the Y is going to be called B or Y, and now suddenly those 2 things are the same. So you can even see a little indicator here that it applied a matching rule. That's how these 2 things were figured out. So if you look at all these symbols, you can see that the first one was done manual, the second one was done through a rule, and now the last one is a weak match. And essentially what it's saying is that, hey, everything else was figured out, so I'm going to take a guess that C and Z should be aligned. And so that's what's happened. So now if I save that view and run the comparison, now I get some details around. This is not normalization, but it has some of the concepts of normalization. Essentially, remember that even if you do normalization, it's also important that things that are matched within your plan. Okay, so that was a little bit about matching and normalization, and now we'll go through some additional comparisons. Now, one thing I'll point out, in our next example, we're going to do it a little bit different. So if you see here in this version, we have 2 environments. Again, it's the same you have the same folder at the top, prod and QA, but the details are that the actual folders are contained within the environment. So it's a little bit different, and you'll find in different situations that these are done differently. And in a lot of cases where definitions are created by us, we'll use that first and second level comparison, or sorry, this first and second level breakdown of environments, and that's good for allowing, for example, if I ever wanted to compare A and B, then that would be very useful. But also it's good for allowing us to do some manual association or just scanning lower level environments. But there could be a situation where at a lower level these things are within the configuration. So meaning here I have a tree that has A, B, and C at the lower level within prod, and I have X, Y, and Z at the lower level within my app QA. So let's go take a look at that particular example. So here, what I've got another analysis plan, and this is comparing the prod with the environments are already aligned as they were before the top level, but there are no lower level ones. So we can just go directly into analyzing the results of the comparison. And when we do that, we can see that we've got now 6 differences. We've got essentially let's sort this by CI. We've got A, B, and C, right? That are, that exist on the source being the prod environment in this case. So the prod is the one that has A, B, and C. And then X, Y, and Z are considered missing, which means that they don't exist on the source. They do exist on the target. If I select it, another way to kind of see this easily is to look on the right side here. So you can see that we've got A, B, and C on the source side. It exists there. It's missing on the other side. And I want to point this out because think about, remember we saw before we only saw the 3 differences. That's because remember that the source dictates what is in context of a plan. We've talked about this a lot in training, but for those of you that haven't done training with us in a while, and that's a little bit confusing, the source dictates the scope of a comparison. So in this case, because the source and target were completely aligned, now all differences are shown. So we see A, B, C. Start to align these environments. And I'm going to show you how to do that. First, we'll go through a little bit. And then, and then we can actually go and execute against that. What I already showed you an example of, but didn't really explain how it works, and we're going to talk a little bit about what these are. Essentially, regular expressions, and these are common. This is a common concept. It's not specific to Evolven. And your development team is probably very familiar with the concept of regular expressions, and you may be too. Regular expressions are essentially these special text strings that describe a search pattern. So think of it as essentially it's saying, I want you to look for this, and if you find it, then do something about it. And in our case, we use it for the purposes of finding when we need to pattern out information. So let's look at a few examples. We talked about the example of random numbers at the end. So in this case, and what we're saying, our regular expression is saying, I want to look specifically for the word myIndex, and then after myIndex, I want to look for, and the square braces are a class, and this class is saying 0-9. So what essentially you can think of this is any digit, and here it says specifically once. So what if I just had myIndex and then square brace 0-9 square brace and not the plus, it would mean myIndex 1, myIndex 5, myIndex 6. Any of those would be valid, but myIndex 12 would not. myIndex 1273 would not. Now the plus sign says take the preceding item 1 or more times. So in this case, what that means is not only does it have to be myIndex 1 will work, myIndex 12 will work, but just myIndex with no numbers will not work. So the plus sign means 1 or more times I expect to see this. If not, it does not qualify. Now, if I wanted to make this optional, instead of using the plus sign, I could use an asterisk, a star. So myIndex and then the 0-9 star would mean that even myIndex would qualify. Now, in our case, we don't, we're expecting that the number is there, so that's why we are explicitly encouraging that. But depending on the context, that may or may not be the right thing to do. Let's look at another example. In this case, we had that 7-zip, 9.00, 9.10, 9.20, etc. So here what we did, and we just did something a little bit different, although it's very similar. This \d part is the same thing as 0-9. So we simply used a different version of 0-9 just to give a different spin on it. But they essentially work out to be the same thing. And also point out that the / is essentially escaping. And so within here, we expect 7-zip, and then we expect this, within this, we expect either a digit or a period. and it is 0.143. It could be 9.00 ... It's really very loose in this case. I've used a fairly simplistic version, but the idea here is that we're simply saying that any combination of numbers and periods, one or more of them, qualify. So even 7-zip 9 would qualify, by the way, or 7-zip period would also qualify. We may not want that, but those would also qualify in this this regular expression. And now here's a different, in this case, before I will just point it out, on the previous slides we were looking at square braces. And pick one, choose one. Here, this is a different kind of a choose. We have a parentheses, and then we've got pipes in between each of our options. So essentially we're saying sales underscore, and then we expect one of dev, QA, or prod in this particular example. One of the options would show up there. Now we could have also done something really crazy. We could have done 7-zip and then parentheses and then 0, pipe 1, pipe 2, pipe 3. So there are options of things that you can put within the parentheses. And parentheses have other meanings in regular expressions. I'll keep it simple for now. But the parentheses are a way for us in this example to basically allow for one of the options to show. So this would be a good format.